So today's video, the problem is called a valid mounting array. So in this problem, what we want to do is to determine if an array is a valid mounting array. That is, an array contains numbers that are increasing in order, then up to a certain point, which we can call the peak. And when it reaches that peak, it decreases slowly up to the end, like that. So if you look at the peak, from over here it is increasing, and then from down here it is decreasing. In case maybe it increases, flattens a bit, increases again, this is not a valid mounting array. So this problem, I actually tried this problem yesterday. I couldn't solve it. Then this morning I had an epiphany to tackle the problem in another light. So I decided to say, okay, valid mounting array, what is a mountain and what characteristics are common in mountains? So if you take a look at this mountain, you have the upside up to the peak and then the downside. So upside of this mountain up to the downside, the same, it goes up to a certain peak, then down. If you look at this ones, they go up a bit, it has a peak and then it goes down. Okay. So with this knowledge, I decided to do something. I'm going to focus on identifying the peak. So if I can identify the peak of this mountain, then I should be able to solve the problem. So let's say I've determined this peak over here. All I have to now do is from the starting point of this array to the peak, are the numbers increasing? And then the other side, I'll look from this peak to the end of the array, are the numbers decreasing? So let's take a look at the solution and how I was able to come up with how to identify the peak. So let's take a look at the problem description. They said, record that an array is a mounting array if and only if the length is greater than 3. So the first condition, I handled it over here. If length is less than 3, return false. Okay, so the array has to be greater or equal to 3. Then the next condition, they said there exists some I. In fact, this plain English that is over here is just saying that for a peak that we have, let's say a peak called I, the numbers at the beginning should increase up to that peak called I. So this is what this statement is describing. Then over here is saying at that peak I up to the end of the array, the number should decrease, should also decrease like that. Anything else is false. So the problem is finding the peak. So first I identify my peak to be 0. Then I used a for loop to loop through the array. So during each iteration, I check if the first element is less than the next element, then I increase the peak. If there comes any condition where this is not true, I break from this for loop. So this break will stop the execution of this for loop. So at each point, I'll be having the exact peak. So let's look at it in example again. So let's say for this example, 0 is less than 2, so we move on. 2 is less than 3, we move on. 3 is less than 4, we move on. 4 is less than 5, we move on. But over here, 5 is not less than 2, so we'll break at over here. So in this instance, this is our peak. And this peak will have an index of, let's say, 0, 1, 2, 3, 4. We'll have 4. So we are breaking over here. If you take a look at this example, let's see where the peak will break at. We have 0 is less than 2, yes. 2 is less than 3, yes. 3 is not less than 3. So the peak will break right here. Okay. So let's move on and let's see what will happen. Okay. So that's how I've been able to identify the peak. Now, the next one is segmenting the array into the upside and the downside. So if I identify the peak, I pick the numbers from the beginning to the peak to be the upside, and then the downside, I pick the numbers from the peak to the length of the array, that is the last element. So that will be my downside. Over here I've added +1 and let's say -1 over here, just so that we don't overflow the index, because when you look at this second condition, which is going to tell us whether the upside contain only elements that are increasing. We'll be using a certain check over here, like we'll be subtracting 1 from the index. So I had to account for it with this plus 1 that I have over here and starting from 1. Okay, great. Yeah, so that's how we are going to find the upside and then the downside. So if you take a look at this, our peak is over here. All these numbers is our upside, and then this 210 is our downside. If you take a look at this one, which is not a mounting array, realize that we determined the peak earlier on to be over here. So all this will be our upside, and then from all this is going to be our downside. Okay, now we are going to determine, how do we determine if the upside is valid and the downside is also valid? Well, to ensure that the upside is valid, it means the previous element should be less than the next element. So once again, I use a for loop, then I start from, I loop through the upside. Then during each iteration, I check, is the element you are currently on less than the next element? Or in this instance, since I'm using -1, I can say, is the previous element less than the next element? If it is, then we move on. Otherwise, return false straight. So the loop will not even continue. This pre-statement over here was for debugging. So the loop will not even continue to begin with. It will just end straight. Like the program, this whole program that we are executing, the function, since we are using return false, it will just end. Then for the downside, I start checking from the peak to the last length of the array. And within each iteration, I check, is the element that we are currently on greater than the next element? If it is, we pass. Otherwise, return false. That is, we stop execution of the program. Now, these conditions that we have over here might seem that like that's all we need. But let's take a look at something. There are some special conditions that are hard to handle. So first of all, I'm going to submit this code. Let me submit this code and see what will happen. It should result in a failure. If it's taking too long, I'll just, okay, yeah, excellent, wrong answer. So this is, it says it's expected false, but I gave true. This is because I wasn't handling a certain condition. How about if the array you are giving consists of only upsides? So there's no downside. So this program, it will not work for that. So in that scenario, I needed to add this to check. So first I had, okay, I'm missing something here, which is, okay, I think there's a bug. This should be upside. So I'm checking if the upside is equal to 0 or the downside is equal to 0. That is, if the array has no upside or downside, we return false, because a mountain can't just be going like this or just going like this. It needs to have an upside and a downside. So this is all these conditions checking for. And I had an extra condition over here to check if there is no peak. So if peak is equal to 0, I also return false. So it will not be, we need a peak before you can have a mountain array. So I'm going to run this code right now. Okay, so upon checking, I think I didn't need to add the upside. I think I had to only check for the downside. Let me run this code again and see something. Sorry, let me submit the code rather. Oh boy, this was just working. Programmers, and it was just working. Okay, now the result gets accepted when I was not checking for the upside. So I don't know why this is like it's working, like it's giving an error, because it makes absolute sense to me. So let me remove the peak and see what will happen. Removing the peak. Oops, wrong answer. Okay, so the peak is needed. The peak is needed. The only thing is that we don't need to check for the downside. I don't know if anybody goes through this solution and then you watch this video, you have any other suggestion, I'm welcome to it. So we don't necessarily have to check for the upside, we just check for the downside. Okay, yeah, so I ran this code. Let me submit it. If the downside is equal to 0, return false. Let's see. Judging, yeah, and it got accepted. So yeah, so all you have to do is always check for the downside. So yeah, shooting this video has also enabled me to identify some redundancies in the code. So this code can be always be improved, it can be made better. Yeah, so there are other methods of solving it. This is how I solve it, and reach out to me, or you can put a comment below if you have any other suggestion. Thank you very much for watching. Please subscribe. Thank you.